You see that bright star up there by the chimney? Well, that's not a star at all. That's in fact Jupiter. And it's a little over half an hour away at the speed of light. Well, aloha everyone. Today we're going to talk about speed and velocity. So, what is the idea behind speed? And how is it different from velocity? Well, speed is what we call a scalar, which means that it doesn't have a direction, it only has a magnitude. It only tells us how fast an object is traveling. So speed answers the question, how fast is it going? We're going to use the letter lowercase v to represent speed. That's going to be our variable for speed. And we are going to usually use it in units of distance per time. So when you see the units for speed, they're going to look something like this. Meters per second. Or maybe miles per hour. Any distance per time is a unit of speed. Okay, so we have that much, but why is the unit that, and how do we even figure out how fast something is going? Well, there's a couple different types of speed that we need to talk about. We have what we call instantaneous speed, and we have what we call average speed. So take this for example. You're driving down the highway, the speed limit is 60 miles per hour. Does that mean that you're going 60 miles per hour all the time? No, especially if you're going on a road trip, sometimes you're going to be stopping. Sometimes you're going to hit construction. Sometimes you might end up drifting off and going a little bit faster. So, your instantaneous speed is how fast you are going at any given time. At that exact instant, how fast are you traveling? Your speedometer will tell you your instantaneous speed. Likewise, if a cop hits you with a radar gun, it will also tell you instantaneous speed. But average speed is a little bit different. We don't usually measure it that same way. Instead, we calculate average speed. And the formula to calculate average speed is going to be this. V average, so we use subscript AVG to represent average speed, is going to be equal to D over T, where D is going to stand for distance, and T is going to represent time. So, speed tells you how fast you went. It's really a measurement of how far did you go in how much time. If you're able to go a bigger distance in a shorter amount of time, you have a higher average speed. To calculate instantaneous speed, on the other hand, we need a little bit more math, and it actually involves derivatives, which are beyond the scope of this course. So because of that, most of the time in this course, if we see an instantaneous speed, and in fact in everyday life most of the time when we see an instantaneous speed, we don't actually calculate them, we measure them directly, using things like speedometers, radar guns, sonar, things like that. Doppler shifting, all of those can help us measure instantaneous speed. So what about velocity? How do we measure an object's velocity? And how does it differ from an object's speed? Well, velocity is going to be a vector, which means it both has a magnitude and a direction. So we need to measure how fast a thing is moving and in what direction. Velocity being a vector is going to answer the question, how fast and in what direction is an object traveling? So again, velocity can come in two types. It can come as instantaneous, or it can come as average. Again, calculating instantaneous velocity is beyond the scope of this course because it requires derivatives. However, calculating average velocity is pretty simple. V, we're going to use an arrow over the top to represent this as velocity, not just speed. Average is equal to, this time it's not going to be distance, it's going to be displacement divided by time. So because of that, first you need to figure out the object's displacement. Then you need to divide by time to figure out an object's average velocity. What does that mean? Well, it gives rise to some pretty crazy things. For instance, if your displacement is 0, your average velocity is 0 as well. So imagine you go from here to the next town over. You then turn around and come back. At the end of the trip, your displacement is 0, which means your average velocity for the entire trip was also 0. Now, at first that seems a little bit weird. Wait, but how fast were you going in what direction? Well, half of the trip you went that way. The other half of the trip you went back that way. So because of that, the two of them basically canceled each other out. Or maybe you can think about it this way. You started in the same place you ended. So on average, you didn't go anywhere. The units for velocity are going to be similar to the units for speed. Actually, they're identical. As long as you have a distance per time, those will be the units for velocity. So, meters per second, miles per hour, furlongs per fortnight, any of those will work as long as the first one is a distance and the second one is a time. And we'll see how those units work out in a second here. Let's try an example and see what happens. Let's imagine we have a toy car. And this toy car travels from here to over here. And we measure this distance to be, let's make it 10 meters. And let's say it travels that distance of 10 meters in a time of 5 seconds. I want to know what is the average speed of the car. And then B, I'm going to want to know what is the average velocity of that car. Okay, so taking a look at letter A, we're supposed to find the average speed of the car. So here's what we want to do. We're going to start from the average speed formula. So V average is going to be equal to D over T. In this case, it's going to be V average is equal to 10 meters divided by 5 seconds. Well, 10 divided by 5 is 2. And then, what are my units here? It turns out they're given right here in this step of the problem. You can see the units should be meters over seconds. Or maybe we'll read that as meters per second. In fact, in physics, the preferred units are always going to be meters, seconds, and kilograms. Okay, so what about the average velocity? How does that differ from the average speed? Well, if we want to find the average velocity, that's v with a vector sign over it, average, is equal to, well, this one's displacement divided by time. So in this case, v average, with a vector sign over the top, is equal to the displacement here is also going to be 10 meters. In this case, it's 10 meters to the right. So 10 meters to the right divided by our time is going to be 5 seconds again. That's equal to 10 divided by 5 is 2. What are my units? Meters per second. And you'll see my direction is even included in the problem. It's 2 meters per second to the right. And there is my average velocity. If the car turned around and came back on the second half of the trip, the average velocity would be to the left. And for the whole trip, there and back, as if it started and stopped in the same position, its average velocity would be 0 because its displacement would be 0. So let's say I wanted to determine the velocity of an actual object, like this toy ice cream truck here. Well, I would need to measure two things. First, I would need to measure how far it goes. And second, I would need to measure how much time it takes for it to go there. So I'm going to use my phone as a stopwatch, and let's see how far it goes in what amount of time. .85 seconds, and 1, 2, 3, let's call that 15 centimeters, 3.15 meters. So now that we've done the experiment, we need to calculate exactly how fast that ice cream truck was. So here's what you want to do when you're solving any physics problem. The very first thing we're going to do in any problem is we are going to draw a diagram. And that diagram should include any known variables. Okay, so it doesn't have to be a good drawing. Here is my ice cream truck. Ice cream. All right, and we measured that ice cream truck went from here to over here, which was a distance of 3.15 meters. So that's going to be equal to D. I also found out that the time it took was 10.85 seconds. So I have my diagram drawn now, and I have identified my known variables. The second thing that we're going to do is we are going to pick a formula. Now, at this point in the course, we don't know too many. In fact, we have exactly 2 formulas. One for average velocity and one for average speed. In this case, we only want to know how fast it's going, and we aren't really interested in the direction that the ice cream truck is going. We know it was coming toward the camera. So because of that, we're just going to find the speed. So I'm going to use the formula for average speed. V, average, is equal to D over T. The next thing that we're going to do is we are going to manipulate the formula if we need to. What do we mean by that? We mean we need to solve it for the variable we're interested in. But in this case, we're actually interested in the speed of the ice cream truck. So that means that it's already solved. We don't need to manipulate this. So this is sometimes. Make that S look a little better. Sometimes you have to manipulate the formula. Okay, number 4. The fourth thing that you are going to do is you are going to substitute. In numbers. Okay, so that's going to be this. V average is equal to, well, our distance was 3.15 meters divided by 10.85 seconds. And then the last and final step is to calculate the final answer and make sure you express the correct units. So number 5, final answer with units. So V average is going to be equal to, let's see here, 3.85 or 3.15 divided by 10.85 is 0.29. Round that to 0. So this is going to be equal to 0.290. And then the units we're just going to grab from right here. You can see it's meters over seconds, so meters per second. All right, so as a recap, the 5 things you need to do when you're solving a physics problem. First, draw a diagram including any of your known variables. Then, pick a formula. Write it down without changing it. Third, manipulate the formula if you need to. Show me how you moved it around. Show me how you solved for a variable. Fourth, you're going to substitute in numbers. And then finally, you're going to give me the final answer with units. So right now, I know a couple things about the distance to Jupiter at the speed of light. From Earth to Jupiter right now, the distance, I looked it up, right now is about 6.526 times 10 to the 11th meters. And that number will go up and down depending on what type of the year it is and how Jupiter and Earth are in their orbits. But right now, it's about that far. I also know the speed of light. I know V for light is equal to 3 times 10 to the 8 meters per second. So if you were to take a flashlight and shine it at Jupiter, how long would it take for the light to get there, assuming any of it got there in the first place? Well, we can do that by solving a physics equation. In fact, we can use the velocity formula to solve for time. Check it out. I'm going to start, like always, by drawing my diagram. So over here is going to be Earth. And then, there we go. All right, and then over here, put some pretty cloud bands on it. Maybe we'll give it a big red spot right here. This is going to be Jupiter. And we know that the distance between the two is going to be 6.526 times 10 to the 11th meters. We also know that the speed of light, V for light, is equal to 3 times 10 to the 8 meters per second. It's actually a tiny bit slower than that, but for our purposes, it's close enough that it will work. Okay, so there was my first step. Diagram and identify my variables. Second step is going to be to pick a formula. So the formula is going to be this one. V equals d over t. Again, I'm using speeds, not displacement or velocity, because we don't really care about the direction here. We just want to know how long it takes. Okay, so then the next step is to manipulate this formula. So I want to solve for time. How long does it take to get to Jupiter? Well, in order to solve this equation for time, I've got to start by multiplying it by both sides by time. So v equals d over t. I'm going to multiply both sides times time. So times time here and times time there. Those are going to go away, and we are left so far with t times v equals d. Now I want to get time by itself, so I'm going to divide by v on both sides. So divide by v, those go away, and I'm left with t is equal to d over v. Now I can substitute. So it's going to look like this. T is equal to, my distance was 6.526. 6.526 times 10 to the 11th meters, divided by 3 times 10 to the 8 meters per second. And for our final answer with units, we are going to get, pause, we get 2,000, wrong side of the pen, 2,175.333 seconds. So that's going to take 2,175.333 seconds in order to get there. I'm going to divide that by 60 in order to put our time in minutes. And that is going to be equal to 36.255, call it, round it to 6 minutes. So really, that's all there is to it about velocity and speed. And judging by how much Jupiter has moved in the time we've been talking, it's really time to go to bed. So, mahalo for watching, and see you next time. Hey, wait a minute, is that Saturn?